Hey guys, how's everything going? Let's forget about the coronavirus and continue our trip to LeetCode. Today, let's take a look at number 85, Maximal Rectangle. Oh, before this video, I'd like to say something about this channel. One day I received a feedback comment from some of our viewers, said that I should do some editing for my video. And he said if I mess something up, and I should cut it out and make the video more, how to say, easy to view or something. I think that is a very nice suggestion, but I would not do that. And as my profile says, this channel is not made from a super algorithm guru. It's made by someone who wants to learn and wants to try. So there will be a lot of mistakes and in the video, and that the solutions the video shows might not be the optimal solutions. Yet I think the process of thinking of the problems, like process of the try, would help much. Sometimes I search on the internet and find the best, how to say, the standard solution to one problem, but I find it very hard to read because I don't know how that solution is generated and how the people think about how to solve it step by step. So I will continue my style of this channel. Hope it helps. But anyway, I thank the guy who proposed the editing thing. And if you have any other idea, please let me know, and just write your comment on below this video. Okay, I'll continue my this one, 85, maximal rectangle. We're given a 2D binary matrix filled with 0 and 1s. We find the largest rectangle containing only 1s. Okay, this one. So for example, we're given this array. We find all the 1s. So biggest one would be this. Largest one would be 6. The other ones like here would be 4. This would be 5, 3. Yeah, this is 3. So I think the first thing came into my mind is that we need to find the time complexity of the brute force one, right? The brute force one with n array. How would that be? So each 2 points in this two-dimensional array would generate a rectangle. Let's say for this point, even itself, it would be a rectangle, right? So rectangle, this would be a rectangle, this would be a rectangle. So generally, there will be m and 2. The combination of 2 out of from m times n, right? This possibility is a rectangle, but we count it twice, right? So two point, and then like say 1, 0. This will be a rectangle, and we are starting with a 0. It will be counted twice. So I think there will be like C2 2. So it is C2 1. Okay, sorry, A2 2. Which one? This should be 2, right? So yeah, so generally this should be the time complexity. As you see, it's very big. How big is this? I'm not sure. I don't remember. It should be like okay, I'll skip this just to do the calculations. It must be very big. So how can we improve? So actually, I didn't come up with a solution for this problem, but this problem is just right to number 85. 85. Wait a minute. 85, 85, 85, 84. Largest rectangle in Histogram. And please, if you're interested, please search on my channel for a last video. There will be a detailed description there. It's actually very long, and we've made to we've made it to achieve achieve the goal with linear time, which is, I think it's pretty good. So if we compare these two problems, we found that these two problems are very similar. The maximal rectangle is much complicated. It's complicated, more complicated than the previous one, but there's a pattern there. So if we reduce this array down to one row, right, like this one, it will be just number 84, largest rectangle in histogram. So number 84 is a special case for number 85 with only one row. Now, so how will we handle if there are multiple rows here? Well, the idea is very simple. If we go up, if we look at this array row by row, we'll find that for the first row, yeah, we calculate the largest rectangle with a previous solution, and then we get the top two row, right? And find the largest rectangle. And remember the top three rows, yeah, top four, yeah, and we can just do it row by row, right? So each, like for the top three rows, there are 3 ones here, so it's for 3 in the 2084, right? At like this, the height of the bar would be the consecutive. I think it's consecutive. The ones, yes. And here, 1. So here, 3, 2. Yeah, for the top three rows, it will be 3, 1, 3, 2, 2 for number 84, right? And for top 4 rows, top 4 rows, it will be here. Obviously, it's 4, and here, because this is 0, we cannot afford create a bar from 0, so it would be 0, 0, 3, 3, 0, right? And for number 84. So the problem become obvious is that we can just count the ones from top row to the bottom row, and if we meet some 0, we just reset it to 0. If it is 1, we continue, we add it to the count, right? So we can say at the beginning it's all zeros, and then 1 0 1 1 0, so it's 1 1 0, and then for this row, because it's 1 0 1 1 1, it's become 2 1 0 2 1 1, and then all ones, so 3 1 3 2 2, and then 1 1 1, so 4 0 0 0 0 3 row. Yeah, so now we can just start with our solution. The first one is copy the previous solution, because it will be part of our solution in this new problem. Okay, we need an intermediate array to keep track of the count of the ones to pass to the previous solution of largest rectangle area. I'll say it would be like count. Okay. So I would initialize it to all 0, but how many zeros there will be? It will be matrix 0 map. I map it to all 0. But this will might be empty, right? So if matrix length is 0, I would say return 0. and the count would be initialized 0. And now we just say for each row of this matrix, for each row index, what we do, for each row we will update the account array and pass it to this function, right? And there's a result. Forget max. I'll say result. Okay, but how would we update the account? It's pretty simple. For let ij equals 0, j smaller than count. This row j, if row j equals 0, then count j equals 0. For the other cases, what be 1, so this should be plus equals 1. Yeah, now the count for each row is updated, and we can just pass it to this function, right? Okay, so max results equals max. Okay, sorry. Let me set the font size bigger. 16 pixel. Okay. Max results. Well, this would be count. And finally, we return the results. So it should work. Yeah, it worked. And the time complexity, because the previous solution would be linear time, and we have this would be n, and this would be, it should be n, and this should be n. So yeah, it's n square. Submit. Hope it works. Yay! And we are accepted and faster than 50%. It's not bad, and yeah, it's not that good either. But I think we're doing great for this one, because great, not great, but so this problem itself is very genius. I think it leads us to, how to say, reduce this problem to a simple form, and find the solution there, and then we can just reuse the solutions we found and make these problems much simpler, right? Wow, this is cool. So okay, hope it helps. I don't know what this should be called. This should be divide and conquer. Divide and conquer. Anyway, I don't know. Divide and conquer. Divide and conquer. It's kind of, but we're not using the recursion. Anyway, so I'll stop here. Hope it helps. And yeah, don't forget to follow my channel, subscribe my channel, and see you next time. Bye bye.